Hello, good evening. Can you see my screen?
Yes, sir.
Okay. Yeah. We'll start in a couple of minutes. Okay, yeah, we'll get started. So, yeah, good evening, all. So, welcome to week 11 or session 11 for this course, Optimization Methods in Civil Engineering. So, I am Diljit Datta from our IISc. So, today in this session, we will be going through the contents that have been taught in last week. That is like multi-objective genetic algorithms, see the basics of that, and then we will see what is differential evolution. There is also a new technique for solving like for optimization problems, and lastly we will see the introduction to Matlab. We will see how to write a code in Matlab, what is the syntax, and how you can solve a optimization problem using like classical optimization problem in Matlab. Okay. Yeah, so first coming to, these are taught in class already, so I'll just brush up the concepts once. So what is multi-objective GA? Multi-object GA is like when you have like two objectives to satisfy in a objective function. That is, we have to.
Sir, you are presenting in screen, not visible, sir.
It's not visible. Okay, one second. Is it visible now?
Yes, sir.
Okay. Yeah, so yeah, in multi-object GA we have more than one objectives to fulfill. That is two objective functions. Suppose f1 and f2. Suppose one might be minimization, one might be maximization, but we have to do that simultaneously. It's not we have to do that separately. So that is why it is called multi-objective GA. And sometimes, most of the times, the objectives are conflicting in nature. Suppose like while manufacturing a car, you want to uh, maximize the mileage and minimize the cost. So it is like that. So you have to minimize the cost of the car, and at the same time you have to maximize the mileage of the car. So these kind of two objective functions you have to satisfy, and there are several this kind of problems that you have to face, and you have to solve this kind of problems. So while dealing with this kind of problems, there will be two search space. One is the decision variable search space, and other is the objective space. So there will be unique mapping between the objectives and the map, and the mapping between the objectives is generally non-linear. Most of the times it's non-linear, but sometimes it might be linear also if the problem is too simplified. And also the properties of the two search spaces are not similar. Like the some search space properties, like how the values of the variables are varying in the search space, it is not similar. Sometimes one might be having an increasing trend, one other might be having a decreasing trend. This kind of things are there. And a proximity of two solutions in one search space does not mean a proximity in other search space. That is also one of the conditions. So to solve this multi-objective GA, there are like many methods, and like there are three or four, we can say, like very well established methods that have been used to solve this kind of problem. One is the MOGA method, that is multi-objective genetic algorithm. So it was introduced by Fonseca and Fleming in 1993. And so how did they do it? Suppose you can see the graph here. So we have two objective functions. One is minimize f1, we have to other is minimize f2, and this is the solution space. In the solution space, you can see there are like samples that are spaced in different ways, and the samples that are marked 1, these samples are like closest to the Pareto optimal font. What is a Pareto optimal font? It is the boundary that satisfies the like satisfies the minimization of either the f1 or the f2 or the both. So this is the Pareto optimal font, and you can see that we can say that all the points that are in the Pareto optimal font are not dominated. That is, they are independent, or these are non-dominated solutions. So, so these solutions that are in the Pareto optimal font, they will be given the rank 1 because they are non-dominated solutions. There is no other solution that is in front of or lesser than these solutions. Now, when we have, so suppose there are 4 solutions in the Pareto optimal font. Now there are these two solutions that are like away from the Pareto optimal font in the maximum in the maximum side. Now these solutions, that is to the right side of the Pareto optimal font, these will be given a rank based on the based on the number of solutions in the Pareto optimal font, and this number of solutions, this rank is called the non-dominated ranking method. So this, how many optimal dominated solutions are there? These are 4. So this will have a rank of 1 plus ni. Ni is the number of solutions that dominate that solution. So these 4 solutions dominate this solution. So this will have a rank of 1 plus 4, that is 5. Again, this also, these two lie in the same like category. So this 5 and the 5, they are not dominated by each other. So this both the 5s are dominated by the solutions that are only to the left of this solution. Okay, so these two solutions are dominated by these 4 solutions, so both will have a rank of 1 plus 4, that is 5. And here you can see this solution, it will have what is the rank. So there are 6 solutions that is being dominated by this solution, so it will have a rank of 1 plus sorry, not 6, I think it should be 7. I think this is a mistake. So there's 3 4 5 6, this rank should be 7. This is a mistake here. So there are 6 solutions dominating this one, so this rank should be 1 plus 6 equal to 7. Okay, So this is how we assign the rank, and after assigning the rank, have we do the use the sharing function and the crowding distance that we discussed in before in like normal GA method. Just the only thing is that while assigning the rank, will be using this non-dominant ranking method in this MOGA algorithm. Okay. So this is the MOGA algorithm. Then this secondly, there is a vector evaluated Vega algorithm. This is called a vector evaluated genetic algorithm. So here what we do, we have this one initial population of, and we have to optimize two functions, that is f1 and f2. So we'll get a mating pool by assigning a fitness value from the two objective functions, assigning a fitness value based on f1 and assigning a fitness value based on f2. So now from the, suppose this is the initial solution space, like 0.1 0.3 like that, you can see this is the initial solution space. Yeah, x1 and x2, there are two values. 0.1 x1 values are this, x2 values are this. These are the whole population. Now we have the f1 and f2. What is f1? F1 is a fitness function based on the first function, and f2 is a fitness function based on the second function. So now each will have a different fitness value. So now what we do, we put the population together and we get the value, new population, that is mating pool based on this f1 and f2. Suppose if p1 is coming from f1, that is like we are using this, we are getting p1 based on the initial, that is the first fitness function, and then p2 we might be getting using the second second fitness function, and p3 it might be coming from second or the first, it might be coming from any one of the fitness function. So like that we prepare a mating pool of the same size as the whole population by taking the fitness functions from the that is from the f1 and f2, and now from that we do the crossover and mutation like we did before. After doing crossover and mutation, we can partition the solutions, and this partition can be done like, suppose the first yeah, suppose if we, for the first one we assign the fitness of 1, for the second one we assign the fitness of 0.8. Now for the third and fourth we are assigning the fitness from the f2 because f2 value is minimum here. So maybe we are assigning the fitness value of from f2 from the third, fourth and fifth, and for the last one again we are assigning value of fitness from the f1. So in this way we get a new population, and from the new population we can again do the crossover mutation and proceed to the next solution. So this is how we optimize using the vector evaluated genetic algorithm, the Vega method. So this is just the basic theory, like it will be clear when we do this coding in the next class. Now not this class, we'll be doing the see the code for this in the next class. Now these methods are that these two methods, they are like more focused on the like dominated part. It is like which solutions are dominating in the Pareto optimal font. Like suppose here this solution will be dominating here because it is the minimizing f1, and this solution is minimizing f2, right? But in between these two solutions are minimizing, but these are minimizing both, but it is not the exact like global minimum. These are like somewhere maybe near the local minima. So but what we do, we sometimes need to see the space that is also in the local minima part, not only on a global minima, that is not in this extreme or not in this extreme, somewhere in between, where it is not purely minima for both, but it is slightly minima for like minima for both of them, but not the global minima for both. Okay, so this is called slightly dominant, kind of dominated but not exactly dominated kind of solution. So for this purpose this method was introduced. It is called NSGA method, non-dominated sorting genetic algorithm method. So what they did, the algorithm is based on non-dominated sorting. The spread of the Pareto optimal front is maintained. Like suppose when we are using this method, now most of the solutions will be getting in this corner or in this corner, but we also need solutions in the middle part also. So in for that case, to maintain, we have to have a solution space that is evenly distributed in the Pareto optimal front. We will be using this NSGA method, and this and spread in the Pareto optimal front is maintained using this sharing function. This dij equal to this function you can see, and after getting the sharing function we can use the crowding distance, and then based on a crowding distance criteria we can get the solutions in the throughout in the that is spreading over the Pareto optimal front. Now this NSGA method, so there is an improved version of this NSGA method, and this is called the NSGA2 method. Now, so what is the advantage of that? This is computationally faster than the NSGA method, and also it is like more efficient for solving nonlinear problems. So NSGA2 is a elitist non-dominant sorting genetic algorithm to solve multi-objective optimization problem developed by Professor Kailyanmay Dev and his student in IIT Kanpur. And it can converge to the global Pareto optimal front and can maintain the diversity of the population of the Pareto optimal front. So this is the main advantage. It can converge as well as it can maintain the diversity over the Pareto optimal front. It is not like the solutions won't be crowded in one part. It will be diversified along the Pareto optimal front. That is throughout the line area of the Pareto optimal front. In non-dominant sorting, an individual X is said to dominate another individual Y if and only if there is no objective of X worse than that of objective of Y, and there is at least one objective of X better than the objective of Y. So this is the criteria. You can go through the like any this one class lectures for the search lectures for better understanding of these methods. And also you can, I think there is a research paper published by KDev. You can also go through that to have a more detailed overview of this method. Okay, so these are the basics of this method. I am only going into details. Now we'll see what is differential evolution. This is also a meta heuristic optimization method. It is a stochastic method, and is based, yeah, it's a population based algorithm. So these are the steps in this differential evolution method. So you have to initialize the population, then we'll do the mutation, then there is recombination, then selection, then termination. We set a termination criteria, and from termination criteria we get the new generation, and then we repeat this mutation, these three processes till we get an optimal solution. So now remember, the mutation in this method, this in differential evolution, is different than that of genetic algorithm. Okay. So suppose this is the, we'll go to the overview of the method. So initially we'll consider a population size of n. Now the population matrix can be shown as, suppose with d xn1 to xnd. So n number of solutions, and g is the generation. That is first generation, second generation. We can get up to capital N number of generations based on the number of iterations. So after we have an initial population, we will get to the next part. It is called the mutation. So how do you initialize the population? You can initialize using a random function that we discussed before. That is, we can generate a random number in the uniform distribution, from the uniform distribution line, and from that random number you can get a value by multiplying with a constant in the range that we want. Suppose you want a random number in the range of 9 to 15. So it generate one random number in the -1 to 1 range or 0 to 1 range, and multiply it by suppose 9. You will get a random number in the value of 9 to 15, or you can multiply it any random number, any like this one, uh, any arbitrary number, arbitrary constant. So after you generate the initial population, you go to the mutation. So how do we do the mutation here? So for a fixed given vector xn, select three other vectors xr1, xr2 and xr3 for the same generation randomly. Now we have a vector, one solution vector, that is xn, and from that we have to select three other vectors xr1, xr2 and xr3, and then we add the weighted differences of the two vectors to the third. So how do we do it? So suppose we take the difference between xr2 and xr3, and the difference is multiplied by a weighting function, that is f. F is generally in the range of 0 to 1, and this value is added to the initial vector as x r1, and from after, if we do this procedure, we will get a solution called the Vn, G plus 1, that is a solution for the next generation. This is called the mutated solution, and this is called the donor vector in this differential evolution method. Okay, so once we get the donor vector, we will proceed to the recombination. So initially, okay, so for vector xn, we are getting a donor vector vn. Okay, for the second generation, this is a mutated solution. Now what is we have to do? We have to do a recombination. What we do in recombination? So a trial vector un is developed from the target vector xn and a donor vector vn. So we already had a target vector xn. So given vector xn now generated the vn g plus 1, that is using mutation, and now using these two, this is a target and a donor vector, we'll get a trial vector called un g plus 1. Now un g plus 1 will have the values like this. So the each element of the un will be dependent on v and x. So it cannot have any other element that is like not there in the vn and xn vectors. It should have all the elements that is either from xn or it's from the vn. Now suppose we want to fill the first element of un. How do we do that? Suppose we generate a random number. If the random number is less than cp, then we get then we fill the first bit of that vector un from vn. And if the random number is greater than cp, then we fill that first bit from the xn vector. Now what is cp? Cp is called the recombination probability. So this recombination probability we can assign based on our requirement, that is based on our optimization problem. Some problems might have a probability of 0.5, some might need a 0.2. So based on our requirement, it will be different for different purposes, and you have to assign that based on trial and error. It's not like there is a fixed criteria for setting this recombination probability. Okay, so we set on recombination probability, and if the random number it generates a random number every time, we want to fill a bit of xn, that is from the un vector, and for each bit we'll fill it based on this criteria. If the random number is less than cp, we fill the vector element from vn g plus 1, and if the random number is greater than cp, we fill the element from xn g, and in that we get the trial vector un g plus 1. Okay, so now after doing the recombination, we have to do the selection procedure. So how do we do the selection? So target vector xn is compared with the trial vector un, and the one with the lowest function value is selected for the next generation. So we got the trial vector, so the next generation will be given like if function of, if the function value of un g plus 1 is less than f of function value of xn, we will get the element, take the vector from un, and if it is greater than fn f of xn, then we will take the value from xn. So this is how we get the next generation using the selection from the two vectors, that is un and xn. So we repeat this procedure till we get the termination criteria. We can set a termination criteria like we discussed before. It's total number of iterations or total number of generations we can set, and after that we will get the optimal solution after suppose n number of generations. Okay, so this was the basic concepts. We will see few basic problems, conceptual problems, and then we will see go to the coding in Matlab. Okay, so in differential evolution, if the donor vector is 8, 9, 10 and target vector is 5, 3, 2, which of the following can be a trial vector? Now I already told that in the trial vector, all the elements in the vector should be either from donor vector or from the target vector. They cannot have any element that is outside these two vectors. Now you can see in a donor vector the elements are 8, 9 and 10, and in the target vector the elements are 5, 3, 2. So there cannot be any element that is outside these two, outside these numbers. Now in the options you can see in the second option there is a 4 here. We cannot see any 4 in the donor vector or target vector. So the second option is correct. That is, it cannot, this 842 cannot be a trial vector since 4 is not there in the donor vector and also 4 is not there in the target vector. Okay. Now in non-dominant sorting of GA, that is NS GA method. The concept of sharing is used to maintain the diversity in the population. I told that the sharing function is used to so that we get the solutions diversified along the Pareto optimal front. So it is to maintain diversity in the population. The third question, the vector evaluated genetic algorithm is used for solving multi-objective optimization problem. And how to do that? So the attempt was made to obtain Pareto optimal front of solution directly. No. The concept of non-domination was used. No, non-domination was used only in NSGA method or and in the MOGA method. Then the third, weighted sum approach was implemented through a GA in which the weight source is selected artificially. The concept of ranking was used. The ranking was also not used. So it is the option C. The weighted sum approach was implemented through GA in which the weights were selected artificially. So in a VECA method, I already discussed here in the first one. So we are selecting the second population based on the weights, that is a fitness function from the F1 and F2, and we are giving the weights based on that. That is, you can see the assigned fitness like either from 1 or from the 2, and this is like we are setting it artificially. So it is option C. Now question number 4, Pareto front of optimal solutions. It helps the user to select the optimal solution according to his or her convenience. Okay, yeah, is a Pareto optimal front. It helps the user to select the optimal solution according to his or her convenience. This is true. In non-dominant sorting GA to NSGA2 method, population diversity has been maintained using concept of crowding distance only, concept of sharing function only, the concepts of both sharing function and crowding distance together, and none of the. So the diversity is maintained using the concept of crowding distance only. You have to remember this. You will see this when you write the code in next class. You write the code for NSGA2 in next class. That is, the concept of crowding distance is only used. The sharing function is not used in NSGA2. In NSGA and NSGA2, the concept of sharing function and crowding distance are used respectively. So this is a basic difference. In NSGA, we use the shading function, and in NSGA2, we use the crowding distance. So these two different methods are used in the NSGA and NSGA2, and this is what and a method of crowding distance makes NSGA2 more efficient than NSGA. Okay, now which of the following statements is correct? NSGA is computationally faster than NSGA2? No. NSGA2 is computationally faster than NSGA? Yeah, this is true. Okay. Okay. Now, which of the following statements is true for an intelligent optimization tool? So, if we have an optimization tool in in a code, that is in a Matlab or R, any software you take, its performance is function dependent. No, it shouldn't be like that. Like it is like for only for some functions it is optimizing properly, for other functions it is not optimizing properly. No, it is not a good optimization tool. Its performance is function independent. It should be independent of the function that we are giving as an input to the optimization tool. So this is a good optimization tool if it is function independent. Now find the minimum value of the function using Matlab or R programming. Okay, we'll do that. Okay, these are codes from Matlab. We will see. Now we will go to Matlab and we'll have a look at the basics of Matlab. Okay, can you see my Matlab screen?
Yes, sir.
Okay. Okay, I will use this. I think Sir has already introduced some of Matlab in the class. I will just go through it once. So CLC, you already know. So this play they are in the left side. You will get the working directory. Suppose this is the path. You can see C users, my name, whatever, and this is the path to the folder where my codes will be saved and where my data will be saved if I save my any of the data. Okay. So in this folder I have this function. So this is called the working directory. Now there will be details. If we click on any of the file, then it might show the details of the file here. Now this is the top part. This is called as editor window. Here you can write a Matlab script. Like similarly we saw in R, we can write the R script. Then at below, this is the command window. You can like write one line of code. or you can check the value of one variable or this kind of things in command window. It is similar to R, that we had this console window in R. And in the right side we have the workspace. It will show all the variables that we are working with and that are being saved in the that are being used in the script. So this command is CLC is used to clear the command window. Okay, so we'll write CLC here. CLC means clear the command window. Yeah, if we write clear, it will clear the workspace. So we have cleared everything. Suppose if you're done with a code, you should clear the workspace because it will free up your memory. Working with big codes, like if you're using too much memory, then your system might lag or it might get hanged if you're working with like huge amount of data in your code. Okay, so now what does MATLAB stands for? MATLAB stands for Matrix Laboratory. So Matlab is very good for doing like mathematical operations that involves matrices or 2D data, and it's also good for image processing, because in images we have the data as what, as pixels, and each pixel it has some bits, so it is a 2 by 2 matrix. So if we have a 2 by 2 matrix, we can operate and do operations on the matrix very efficiently in MATLAB. So MATLAB is very good in that. So that is why it is called matrix laboratory. It operates in the terms of matrices. Now, how do we introduce a variable in MATLAB? First, suppose we want a vector x. So this is called, suppose we write in R, we used to write C bracket something like that. So to introduce a vector, here we need not write any C or anything, and we just write x square bracket 1 2 3 4. If we separate by comma, it means it is a vector. And this semicolon, yeah, now this is the important thing. If you don't give the semicolon and you select and press F9, you can see x is coming also in the command window, along with the it is coming, it will come in the workspace, no doubt, but it's also coming in the command window. But if you give semicolon and then run, it won't be showing in the command window, it will just show the values in the workspace. Okay, so this is the, like, you should keep the semicolon so that while running the code doesn't display everything in the command window. It is not required always. So we have got x. So if we add number 2, it will be similar like what we did in R. That is, it will be adding 2 to all the values. That is 1 plus 2 3, 2 plus 2 4, 3 plus 2 5, 4 plus 2 6, like that. Then we generate one more vector y, and we can suppose 5 minus 2 3 7. If we do x plus y, it will do the summation element wise. If you simply write x plus y, okay, I will remove the semicolon to see the values here. Okay, you can see it is element wise addition is been done like in x plus y. But if suppose x y is not the same size as x, then what will happen? Then it will give error. In R, what happened, if we, even if we did this addition, after that the fourth element is automatically taken as the first element, is it comes in a rotation pattern. But MATLAB doesn't do that, because MATLAB works in matrices, and if there is an empty space, it will won't fill any value in that. So it is the, like, you can say, advantage or disadvantage based depending on your work only it will say. But yeah, so you have to remember this. In MATLAB, you cannot operate on two arrays that is differing in size. Now, if we do x dot star y, it will do the element wise multiplication of y. So in R, if we simply do the star symbol, it is directly do the element wise multiplication. But in MATLAB, only star means matrix multiplication, and for the doing element wise multiplication, we have to put this dot in front. This dot means you are doing element wise multiplication. And to do the matrix multiplication, you cannot do this x and y directly, because x is a 3 by 1, 4 by 1 matrix, and y is also 4 by 1. But so we will have to convert y into a 1 by 4 matrix, because you can see we have to note that the number of rows in X should be equal number of columns in Y. So we multiply Z equal to X star Y transpose. Y transpose is given as this Y dash and Y apostrophe, yeah, Y apostrophe. So you can see Z is coming. It is X star Y. It is 38. We'll also do a multiplication for a like whole matrix also, we can do that. And also when you are taking the power of x to the power x, suppose, or x to the power y, you need to do in a dotted form only, because this is else matrix it will try to do matrix multiplication and this will be fail, this method will fail. So if you do x dot star x, so it will be 1 to the power 1, 2 to the power 2, 3 to the power 3, and 4 to the power 4. Okay, so this was about how to generate vectors in Matlab. Now we'll see about the generation of matrices. So when generating matrix, suppose when you are giving this comma, it means the elements are in the same row. 1, 2, and 3. You can give comma here, or you can also remove the comma. It doesn't matter. Okay. So if we keep it like this, these three elements will be in the same row, and after semicolon, the other next three elements will be coming in the next row only. So this semicolon is used to put the elements in different rows in Matlab. So let us see. I will run this. So you can see 1, 2, 3 is the first row, 4, 5, 6 second row, and 7, 8, 9 in third row. This is a 3 by 3 matrix. So let us do B. Okay. We will write this matrix B also. Now we got A and B, so let us do the matrix multiplication. A star B. So yeah, if we run this, this is the matrix multiplication of A star B, and if we do A dot star B, it will do the element wise multiplication. So you can see 1 into 1, 2 into 2, 3 into 3, 3 into 1 into 1, 2 into 1, 3 into 1, 4 into 0, 5 into 0, 6 into 0, 7 into 5, 8 into 5, 9 into 5. So this is how it is the elementary multiplication. Else, if you don't give the dot, it will give to the matrix multiplication. So this is the important difference. This keep that in mind. So now if we want to generate a matrix of ones, so this like you want all the one in a matrix. So in that way, you can do using this F9. So if you write here A. So now this is a very important way. So you can also give 4 comma 4. Yeah. So once a 4 comma 4 means once uh, first the number shows the number of rows, the second number is the number of columns. So if you write ones of 4 comma 4 means it will generate a matrix of ones with n like 4 rows and 4 columns. Now why it is important? So suppose in most of the codes, like you want to like initialize a matrix. So initially we want all the values in the matrix to be 1, and from that we want to generate the uh, we give the initial value of the matrix to be 1, and from that you want to do the operations. Because if you want to start doing a function, suppose an even optimization problem, we need an initial point, right? Without having the initial point, we cannot do the solution in classical optimization. So For getting an initial point, you can set it as 0, you can set it as 1, or you can also set it as something like, suppose if you multiply with 7, so it will give all the values as 7. Okay, so this is an important matrix when you want to initialize a matrix with some value. After that, it can generate do the operations and get the values in each of the cell in the matrix. Similarly, this is zeros. Zeros command is generate the initialize a value from 0. If we give only one command, it will give a n by n matrix. Uh, you can see 4 by 4. If we give two commands, 4 comma 3, it will give a what 4 by 3 matrix. So this is a similar way you can get a matrix of zeros. Now there is something called ci of matrix I. When you give this function I, it will return a matrix. Suppose if we run this, what we get? We get a matrix with the diagonal elements as 1. If we give it as a 3 by 3 matrix, it will fill the main diagonal as 1. So to getting an identity matrix only, we are using this I function as the identity matrix. So just remember in that way. And if we want to extract the diagonal elements of a matrix, we can do that using this function, that is diagonal of the matrix. So we're getting the diagonal elements of this matrix. See, we can also give the diagonal A. You can get the diagonal elements of the matrix. And lastly, this is the random function. This rand function is used to generate a random matrix with m rows and n columns. M, like here it is 4 rows and 3 columns. So if you just click on that, a matrix is generated with the values in range of 0 to 1. All our random values will be in the range of 0 to 1, and this is generated from the uniform distribution randomly. Okay, so this was about matrix. Then there is how to write a for loop in Matlab. So the for loop syntax is like this: for I equals to something 1 to 7 or 1 to 100, whatever you write the function value in the between, and at the last you have to write the end. In R, if you remember, we need not use this end function. So for Matlab, we have to write this end function. Suppose if you write this, run this code, we will get, you can see why matrix we are getting here, and yeah, we will just write. It is like what, for 7, yeah, 7 elements, and it is given as 1 square plus 1 square, 2 square, 3 square, like that. For each I, it is giving the squared value. Similarly, for while loop, syntax is again similar. We generate an initial value of I, while we write the condition while I is less than or equal to something, and we have to put the end at the last. Okay, so this was about the functions. So we'll see the one or two questions that was there in the like previous year assignment. Okay. I think this, yeah, we'll run these two codes. For first question, what E is given as comma 4. The next column 5 comma 6 comma 7 comma 8. So 2 rows. So we get E. Now E of, yeah, 3. This is similar to R. In R, what we saw, E of 3 comma this column means it will extract all the elements from the third row. If we give the number here, it means the which number row, and if we give column means it will extract all the elements in that row. So E of 3 comma dot is assigned to what? Now we are in a so we are adding a third row to E by using this command, that is 10 4 22. So what does this command say? It says it will generate four numbers in the range of 10 to 22 at an interval of 4, that is 10 14 18 and 22. So we are getting a, you can remember if you remember here, you can see E had only two rows. Now we are adding one more row to E, that is the third row, and this third row element is given as this function. We got the third row. Now we get the I of this matrix. I means what? Okay, so if you're getting a I, that means yeah, it is simply identity matrix only, 1 1 1. But yeah, if we get a diagonal of E, what do you get? You are getting 1 6 and 18. So this is a simple question here. Now we'll solve the this try to solve the second question. X is given as -2 to 4 in the and at the interval of 0.1. Y is equal to 3 dot 3 into x cube minus 26 into x plus 6, and yd is equal to 9x square minus 26, and y double d y dd means yd is the derivative of y, and y dd is the double derivative of y. So we get these functions, get the values. Now we have to plot. This plot is not required. Let us see what is, we have to find z1, z2 and z3. So what is z1? Maximum of y. Yeah, so let us run this command. We get 94. So in this range, the maximum of y is 94. Now yeah, z2 is equals to maximum of yd. If you run this again, you are getting the values 118, and z3 you are getting the values 72. So the answer is 94, 118 and 72 is option A. Okay. So you can also get the minimum using the min function if you want.
Here for minimum or maximum, we cannot put any minus sign, sir, just like R. For maximum or minimum, we just have to write the function only.
Yeah, just the function, yeah.
Now, one case we are putting some minus sign before the
Yeah,
function, no,
that
sir.
is for optimization when you are doing the
Okay,
optimization.
okay, okay,
This is just the I am showing the function how to do that.
okay, okay.
Okay, so yeah, we have solved these two questions. We'll solve one optimization problem now. We have gone through the basics of R. Yeah. So in Matlab, so there will be two types of one is single variable and other is a multivariable optimization. So how do we introduce a function here? So you have to write the function in the form. Suppose uh, You can see y is a function of x. Suppose this is the function x squared plus 54 by x. So we write the function in this form. That is y is equal to at the rate x, and at the side we write x squared plus 54 is the function value. So this is generate. So let us first we'll clear everything. So this is generate a single variable function. Press enter. A function y is generated that depends on x and the value is x squared plus 54x. Suppose if you write y of 1, it means at x equal to 1, what is the value of y? It will give. So it will giving the value of 55. So okay, that is 1 plus 54, that is 55. So this is how generate a one variable function. For two variable again same. Instead of x, you write at the rate x comma y, and then you write the function at the side. So it is just you write then f2 of something, you can get the function of two variables. Now there are three other like commas. These are to generate the x line, y line, and reference line. So this is for plotting that you use this f line and h line and y line, h line and v line function in R. So similarly in Matlab, in plotting, this x line is generate a vertical line, y line is getting for a horizontal line, and ref line is to generate a line with a slope m comma n. Here in this code, here 4 is the slope and 2 is the intercept. Okay. Okay, so these are three commands. These are like commands that will be useful for plotting. Okay, now we have this single variable, but suppose if we have a vector, x is a vector, and we want to get the value of the function for each of the value, for each of the element in the vector. So how do we do that? uh, we can write f of 1 as this way, as x dot squared plus 54 dot by x, that is for each of the element we're getting the value of f1, and we can then just simply see and plot. You can see the plot. It is a hyperbola. And there is one more command. It is important command in R, that is the hold on hold off. If you want to plot two graphs in one plot, so in that case you use the hold on hold off function. So here suppose you generate a value x from 0 to 50 at a interval of 10, it is 5 variables. Then y1, for each of the value of x you get a value of y, that is sine of x. Okay, now we plot of x comma y1. Okay, so you can keep seeing the plot. This is the plot of x comma y1. We put the title. I think we have to use combine plots. Now we use the hold on function. If we put hold on, what will happen? On top of this graph, it will plot another graph. Another graph is sine of x by 2. So we calculate this function and then plot. Okay, so now you can see both the graphs are plotted in the same plot. So this is the use of hold on hold off function. You can also plot a third plot till hold on is on. You can see this third plot is plotted in the dots because we use a scatter function. And now we do the hold off. That is, after this the plots won't be plotted in the same function. There is one more last function. This is called fsurf. This is for plotting a 2D surface. So this function is given in this way. I think yeah, this is. So this is a function. You can plot the fsurf function. These functions are useful for plotting and seeing your optimization functions, like to use the contour function and this plot 3D function in R. Similarly, you can use it. So yeah, uh, now we have to see the classical optimization. So in classical optimization, what we decided, we discussed that we should always do the minimization problem. That is, we have to minimize the problem. So it's a minimization kind of, if our objective function is a maximization kind of problem, we'll convert it to a minimization by multiplying it by a minus. So here our objective function is x squared plus 54 by x, and it is already, we want to minimize this only. So we don't want to maximize, so we are not multiplying it by minus. If we want to minimize, want to maximize, we have to, if we have only a maxima in that, so then we have to multiply it by the minus sign. And the function that will be used is called f min bnd. This function is used for unconstrained optimization, that is single variable function or multivariable function also, and it is used for like unconstrained optimization. And for constraint optimization, we use the function called f min con. So just remember these functions. And what is the syntax? This syntax is the first command will be the function, second will be the lower bound, third will be the upper bound. And at last you can give some options. These options are to display the function values, then display the number of iterations, and these options you can give. You can see the syntax in, if you just type in Google the function name, you can get the Matlab. Uh, the Matlab, this one website will show all the commands that are being used in this function. Okay. So for us, our objective function is this one only. Sorry. We get our objective function. Our lower limit is 0 and upper limit is 11. We put this, and now we have these options. That is, we want to display the function, we want to get the plot functions, we set these options, and now we get the optimal value. At what optimal value we have the we get the minimum of this function. So we get on this, and we can see this is the function value after 9 iterations. And what is the value of x? That is the, that we are getting at where, which we are getting minima. We are getting the minima at a x value of 3. And what is the objective function value? The objective function value is 27. So you can see at 3 we are getting a value of 27, and after that there is no significant decrease in the objective function value. So at 3 only we are getting the minima. So yeah, this is a classical minimization problem using classical method in Matlab. Okay. Similarly, we can do the multivariate optimization. That is, you can use two functions instead of one. But when you are, similarly in R, we discussed that when you give the function input, we give it as a vector. We don't give as two variables. So here also we will give x as an input vector, and from that we will get the optimal solution. Now for multivariate optimization, the function that is being used is called f min search. This is, this function will start from an initial point. As initial point, suppose what we give a 0 comma 0 or 3 comma 3, 1 comma 1, whatever you want. Based on a requirement, you can give that. So we'll just run this to clear our objectives. Yeah. Now we give the objective function. You can see we are x1 plus x is a vector. If we give x1, means it is taking the first element of the vector. X2 is second element of the vector. So our objective function is given. It's decided now. Now we get the initial value. Initially, it will start from the search from x naught. It is 3 comma 3. And options, it is not compulsory to always give the options. I want to see after each iteration how the values are varying, so that's why I'm giving the options. And now we use the f min search. So what are the commands here? In f min search, we give the objective function, the initial value, and the options. So just give, you can see after 35 iterations we are getting the minimum value. After suppose I think 10th or 11th iteration, we'll see then the minimum value what we are getting. X is getting as 3 comma 2. So we also see a display. I'm getting the minimum value of 3 into 10 to the power minus 8. So it is near 0 after 10th iteration, and the value is what, at 3 comma 2. Okay, so this is the, just remember, when you are doing it for a multivariate search, we have to give a initial point and we have to use the function f min search. Okay, so we had one problem, I think, right? So in the range of minus 10 to 10, we have to optimize this function, 2 into x to the power 8 plus 4x minus 25. Right, this is the function, right? So we have to just minimize this function. So what do? We give the lower bound and the upper bound. And now we do the, so we'll uh, run this command and we'll see what we'll get. Oh, sorry, I did this mistake. Yeah, we got x. So what is the value of x? X is minus 0.282. And I also have to get the function value of x. Minus 27.87. You can see here minus 27 is the option B, minus 27.87 is the right answer. Okay, so yeah, this was about constraint optimization, unconstant optimization. Now we'll just have a glance at the constraint optimization method. So in constraint optimization, we can have what, linear constraint as well as non-linear constraint, and in both non-linear and linear we can have equality and inequality constraints. When we have a non-linear constraint, we have to write the function ourselves. There is no the function is not directly taken into the method. But when we have a linear constraint, the just in the this f min con function, you just have to give the, that is the coefficient matrix of the linear equations. And yeah, and that's all, like for both linear equality and linear inequality constraints. But when you have non-linear constraints, we have to write the function like full function. So yeah, let us, well, close all, write all. So we write this objective function, that is x1 into x2 into x3. Yeah, yeah, the function is this one. I'll show the this one. I think it was running class also. This is the function, that is minimize fx equal to e to the power x1 x2 x3 x4 f5 minus 0.5 x1 square plus x2 square plus x1 whole square. I think
Before that point 5 minus sign should come, sir.
where
The function after x power 4. That x power 5 is missing, and after that minus 5 should come. Minus 5.
yeah, that's what. And this is minus, right? Minus of, yeah. Now is it fine? X1 into x2 or x1 square cube plus, what is the function? X1 cube plus x2 cube plus 1, right? X1 cube plus x2 cube plus 1 whole square minus 0.5 into, there should be one more bracket here. Yeah, now it is correct, I think. Yeah, so this is our objective function. So we have to give the lower bound as well as upper bound. So yeah, I told it will be important that we give the lower bound and upper bound. So for lower bound we give, suppose, what is the, in the question it is mentioned, it is minus 5 to 5. So we give minus 5 into once for lower bound. That is, we are getting x as a vector of 5 variables. So since your x or x1 to x5, similarly we give the upper bound. So 555, we give the initial value, initial point, suppose we gave some points randomly. Okay, so I think the initial solution we will see what is like for x naught, what is the solution. So we just run the function. I think should be a comma here. Yeah, initial objective is minus 5.64. So now in this question, what is the constraint here? The constraint is x1 square plus x2 square plus x3 square plus x4 square minus 10 equals 0, x2 x3 minus x4 5x4 is equal to 0, and x1 square, and there is no linear constraints here. All the constraints are non-linear, so we have to generate a function ourselves. So now in this, if you go through the code, like what is the method of the, the syntax of the code in Matlab, in MathWorks website, you will see that A, B are the linear constants. A is the linear constants, B is a linear inequality constants, A equality is linear equality constant, and B equality linear equality constant. And A is the for the matrix, and B is for scalar functions. So A is empty, also B is empty, A equivalent, A equal is empty, B equal is empty, and in is integer value input, no, it is also empty. Now the nonlinear constant, how do we give nonlinear constant? We give nonlinear constant as a function, and this function, it is always better to write this function in a separate script and give the function name, script name, as the function name. This is very important. In MATLAB, when you're writing a function, you have to give the script name as the name of the function, or else you can write the function in the same script only, but you have to write the function at the very last of the script. There cannot be any single line of code after the function, else the function won't run in MATLAB. It will give error. So for safety, I am writing the function in a separate script. I am giving the function name as nlcon and also a script name as nlcon, and there will be uh, two inputs, that is C and C equivalent. No, sorry, C, there are two outputs, C and C equivalent. So the C equivalent, it will have three elements. One is the C equivalent ones. It is a vector of three elements. The three variables are given as this, as x1 square, x2 square, x3 square, x4 square, x5 square minus 10. The second element in the vector is x2 into x3 minus 5 into x4 into x5, and third element is x1 cube plus x2 cube plus 1. And the inequality constant, it is the C, it is empty. So we save this function, and also we can run this. Okay, I think it is fine. Not it is all x. Yeah, we'll try to run this. Now we give the nonlinear, assign a nonlinear constraint to nlcon. Now we use the f mean con function. We have the objective function defined. We have x naught initial values a and b. We have given a equivalent, b equivalent. We have given lower bound and upper bound, and also given nonlinear constant. So let us run this function and see what we get. Okay, there is no error. You can say local minimum found that satisfies the constraints. Optimization completed because the objective function is non-decreasing in the feasible directions to within the value of the optimal tolerance, and the constraints are satisfied to within the value of the constraint tolerance. So now let us display the solution. Oh, I think so let us display. I think if we put x1, it will display like this. Yeah, so the first value is minus 1.71. So let us get all the values. We'll get the second value also. This is x2. X2 is 1.59. X3 1.82. X4 minus 0.76, and lastly x5. So we got x, and now like if we simply give display x, in that what it shows, if we, yeah, it will show the vector x. Now let us display the object. Is the function value at the minimum. It is 0.0539. So yeah, this is the way you can solve this constraint optimization using this f mean con function. So there are some other problems you can solve. So this is how you can solve in a classical problem using in Matlab. In the next class you will see for similar problems. Yeah, for similar problems, how we can use this particle storm optimization, or this NSGA2, or the genetic algorithm for solving this kind of problems in Matlab. We have seen in R. For future, I will always say that it is better to use R because R is more convenient to use. It is a better community. It is easier to operate. This faster than Matlab. There are a lot of advantages, but you should always also know how to operate in Matlab because it is important. Okay. It is easy, good to know, because sometimes it might be required that in some course you attend, the professor tells that, yeah, you have to solve all the questions in MATLAB only. You cannot use any R. Because the one thing is that when you're using R, there are a lot of libraries in R that is already predefined. So you can simply use the library function and simply calculate, do the optimization anywhere or any function evaluations. But when you're using MATLAB, most of the times you have to write your own code. And it is good to write your own code for getting a function, because it will help you learn and get the more better grasp of the concepts. So yeah, that is why MATLAB is important. And also, while plotting some mathematical functions, for plotting also MATLAB is very good in most of the times, but it has some disadvantages that I have already discussed. So yeah. So okay, any doubts you have? If you have any doubts, you can ask me, or else we will end the session.
Sir, in that R program, while writing that monitor function, I'm writing some having some doubts, sir.
Okay, what is the doubt?
And that monitor function actually we are writing in 2 3 lines. It continues up to 2 3 lines that program.
Yeah.
But we are starting with bigger bracket. I am not closing the bigger bracket. The same line is showing some error message. That
uh,
monitor function.
Error, what error is it showing?
Some bracket something is showing. Because that we are starting with one bigger bracket in first line. After
Okay.
2 3 lines only we are closing the bigger bracket, no sir. Completing the
Yeah,
two three
yeah.
lines program. So in that case, it is bracket is coming only on left side only. I'm not closing the bracket on the same line.
Okay. So in that case, yeah, sometimes if you're writing in a second line, then I think it is sometimes the R confuses it to be in a different code, like different line of code. So
Or
try to write.
suppose if I can write continuously, sir. There is no problem.
There is no problem. Yeah, just write in the same line. There is no issue in that.
Okay.
Okay. Yeah,
Oh,
try for giving a different line. I think it might give error sometime. Yeah, it might give error.
okay. So the functions, whatever giving that lines that can I can continue same line, no
Yeah,
problem.
yeah, yeah, yeah. No issue.
Writing.
No issue. Yeah. And also, yeah, you can give if there is a you can say like put in next line after comma. If there is a comma, no, after comma you can put an enter and put in the next line. Just check that, but don't put
Okay.
enter in between. There is the separation of functions.
Okay, sir. Okay, sir.
After
Okay,
comma only give it. Don't give it before comma. Okay.
okay, sir.
Yeah. You can try that. It might
Okay.
work
Thank
that
you.
way, or else
Thank
you
you.
can
Thank
write in
you.
the same line. No
Thank
issue.
you. Thank you, sir.
Okay. Anything else?
Thank you, sir. Nothing, sir.
Okay. Okay. Fine. Fine. Okay, then we'll end today's session. Thank you for attending. Yeah, have a good evening.